Okay, welcome to the angle pairs webinar. If you haven't gotten to this chapter yet, it's a pretty tricky one, so make sure you're paying attention. And if you're past it, then a lot of this stuff should help you with things like proofs. Here's the things we're going to be going over today. What is an angle pair? How you guys should be taking notes so that you can do all the stuff that gets a little bit difficult with proofs and everything. Examples, practice, and then we're going to do some postulates and theorems. So first off, what is an angle pair? One thing you need to notice is that a pair is always two. So if something asks you to name an angle pair, you need to make sure you name two angles. Okay? Some of you get confused when you see something like complementary angles, and you think anything that's 90 is complementary. It's only complementary if it's two angles that add up to 90, because that's a type of angle pair. If you just see an angle that's 90, it would be a right angle. So let's go on. This is what it should look like when you take notes. This is an example from a previous chapter measuring segments. But this is how I recommend you take notes. Always have an example so that you know what it looks like when you have that type of definition, and put it in your own words so it gives you a clear understanding of what it is. The reason I ask you to do this is when you do proofs, a lot of times your answer to each proof or your justification is going to be a definition. So if you have all your definitions in one place with examples, it's going to be easier for you to recognize what definition you need to put as your justification. Okay? So let's go on to some of the definitions for this chapter. All right. Our first word is adjacent angles. Directly from the book, this is the definition I got. Two coplanar angles with a common vertex and no common interior points. In your notebooks, you guys should put this in your own words. These are the words that I used. You guys might understand it differently, but just know it's something that looks like this. Okay? Both of these are adjacent, all right? This one is also collinear, which means that they're two angles on the same line. 1 and 2 are two adjacent angles that are collinear. 3 and 4 are adjacent, but they're not collinear because they're not on a line. But they're still, here's their common vertex, and here's the common side, okay? The next one is vertical angles. This one's important because one thing we know about vertical angles is that they're equal. So we're going to use that fact later. Okay. I put from the book, it says exactly two angles whose sides are opposite rays. In my own words, the best way that I understand it is two angles across from each other when two lines cross. So put it in your own words the way you understand it. If we look at our picture, 3 and 4 are vertical angles. That's their relationship to each other. And 1 and 2 are vertical to each other. All right, 2 more definitions, and then we're going to do some examples together, okay? So it'll get more interesting, I promise. Complementary angles. This is like what I was talking about before. Two angles whose measures have a sum of 90. And we call them complements of each other. In my own words, I put just two angles that add up to 90 degrees. Here are 2 examples. They do not need to be adjacent, but if you look at 1 and 2, these are 2 complementary angles that are adjacent. These 2 angles, A and B, are complementary, but they're not adjacent. They don't need to be next to each other. Okay, is anyone else having trouble hearing me? Okay. Well, if you can't hear me, or you're having a little bit of trouble, just try to look at the pictures as much as you can, and anything you don't understand, just send me a message and ask me a question about it. Give me 1 second. Okay. All right. So just look at the pictures and read what I have. If you have a question and you're having trouble hearing, just type it in the chat box. Okay. Next, we have supplementary angles. I'm going to talk a bit slower to try and help those of you who are having trouble hearing. This I got directly from the book. Just two angles whose measures have a sum of 180. Each angle is called the supplement of the other. This is it in my own words. Put it in your own words. Here are two examples. Here we see two angles that are also collinear, 3 and 4. So if they're collinear, that means that they have to be supplementary. But the converse isn't true. They don't have to be on a line for them to be supplementary. So these two angles, if we add them together, 137 plus 43, we get 180. So even though they're not collinear, they're still supplementary angles. So let's practice with some of the angle pairs we've learned so far. Here's your chance to type in the chat box. So put your answers to each question. What kind of angle pair are angles 1 and 2? So 1 and 2 are right here, so tell me what kind of angle pair those are. Okay, good. They're adjacent and they're also collinear. So some of you said adjacent and some of you said collinear. You're both right. All right, let's go with collinear for our next question. What other angles are the same type of angle pairs as angles 1 and 2? Go ahead and type in your answers. Okay, I got another good answer from somebody from the first question, which is also true about them, that they're supplementary. Good job, Kiara. And a lot of you are giving me for another pair of angles that are also collinear is 5 and 6, but there's more. What other pairs are also collinear? Good, I got another good answer. Okay, good job, Andrea. All right, good. 4 and 3. 8 and 7. Now, nobody has given me any of them that are on this blue line, though. There's some that are also collinear, but they're on this blue line. Good. Hafsa, that's 1. Okay, good job. One and 4. Okay, 2 and 4, they're vertical, so those aren't going to be collinear. They have to be on the same side of the line. 5 and 8. Good. 2 and 3, and 6 and 7. All right, you guys are doing really good. All right, let's move on to the next one. Now, what kind of angle pair is 2 and 4? All right, I got a lot of right answers and some that weren't. The answer is vertical angles. If you put complementary, that's not necessarily untrue, but we can't tell with what we have here whether or not it's true. They could be 45-degree angles and then they would be complementary, but since we don't know what their measures are, we can't tell that. So the only kind of angle pair that we can establish is that they're vertical because they're on opposite sides of these two lines that cross, or that they have opposite rays, which is the definition in the book. Okay, what other angles are the same type of angle pair as 2 and 4? Good. Good. Very good. Somto, can you give me another one? Good, I'm seeing a lot of good ones. All right, so let's go ahead and list these. Good, 5 and 7 is 1. All right, so we have 1 and 3 is also vertical. 8 and 6. 5 and 7. Did I miss any, or is that it? Yeah, that's the only one besides, those are all of them besides 2 and 4. All right, good job. All right. Now here's theorems that have to do with these angle pairs. This is the stuff you guys are going to be using in proofs. Okay, so this is stuff you want to know. Linear pair postulate. We already talked a little bit about linear pairs, and that they are supplementary. So that's all this is saying, is that two angles that are a linear pair are supplementary. This is that in my own words. And here's an example. These two angles are a linear pair because they lie on this line down here. So if we add them together, this is 45, this is 135, and then we found out it is true, they add up to 180. And that's a definition of supplementary angles. Next one, vertical angles theory. And that just says that they are congruent. In my own words, I just put they're equal to each other. And here's an example of that. Same picture that we had before of vertical angles, but this time I'm stating that 1 and 3 are congruent. That's what that little equal sign with the squiggly on top means. And 2 and 4 are also congruent. Okay, that vertical angles is probably one of the most used theorems here. Congruent supplements theorem. So we all remember that congruent angle or supplement angles are angles that add up to 180. This one just says that if two angles are congruent, then they're supplements of the same angle. Or if they're supplements of the same angle, then they're also congruent. So here's an example. 1 and 3 are supplements, and 2 and 3 are supplements. This is a lot like transitive property, but it's just called something else. So since this is supplementary to this, and this is also supplementary to this, that means that 1 and 2 are equal to each other. Okay, if you guys have questions while I'm going through these definitions, just go ahead and ask those. Congruent complements theorem is almost the same, except we're talking about complementary angles, which, if you remember from before, are two angles that add up to 90 degrees. So if two angles are complements of the same angle, then the two angles are congruent. Okay, so here is our congruent complements. We have 1 is a complement of 2, and 3 is also a complement of 2. So since they're both complements of this angle, that means that 1 is equal to 3, which we put down here. Okay, I saw somebody left. If you guys just get disconnected, you can use that same link to get back in. But now we're going to do some review with the theorems and postulates. So using our theorems, we can find 1, 2, and 3. So let's start with angle 1. What do you think angle 1 is equal to? I have 2 answers. Good. Very good. And remember that little square means it is vertical. Good job. It's vertical to this angle, and remember this angle, this little square here always means 90 degrees or a right angle. So a lot of you got that right. It's 90. And what theorem did you guys use? To figure that out? Okay, good. I got some right answers, some not right. Remember that complementary angles are an angle pair. And angle 1 isn't complementary to angle 3, to this right angle, but it's opposite of it. So it's actually vertical angles theorem, which a lot of you did say, but some of you got a little bit confused because of the 90-degree angle. Now remember, only this angle is 90 degrees. So if only one angle is 90 degrees, it can't be complementary to anything. It has to be two angles that add up to 90 in order for it to be complementary. So let's move on to the next one, which is angle 2. What do you guys think angle 2 is going to be? All right. Now, angle 2 is right here. If we look, these two lines cross each other, and on the other side is 50. So across from angle 2 is angle 50. Since we know that vertical angles are congruent, angle 2 is going to be 50. And what theorem did we use there? We're only going to be using one theorem for this question, and the next one we're going to do a different one. So you guys should be able to get that. Good. All right, it's vertical angle theorem. Good. All right, make sure if you don't know or you have a question, just type your question in there, okay? All right, and the last one is angle 3. Good. We're gonna use the same theorem. Look at two lines that cross each other and see which one is across from it, from angle 3. Good, it's 40. And that's the same theorem. We use the same one for all 3 parts. Okay. Now when you guys are doing proofs, you're gonna have to know stuff like that where you say angle 1 is 90 would be your statement. So let's do an example that looks like that. Suppose we had over here is our statements and over here is our justification. We could make a statement that angle 1 equals 90. And then how do you know is our justification? And we would say vertical angle theorem, which is kind of hard to type, but if you guys have seen the proofs yet, I'm just going to put TH for theorem, you know that you have to do this 2-column format, and that's basically the idea behind it that a lot of people get confused about. It's not really as complicated as you make it if you just make a statement and then write how you know it's true, which is just what we did here, and you all did a great job of doing that. Now we're going to use another theorem. We know from our statements here, CBD is congruent to EFG. Okay? We need to find what is the measure of EFG. We need to do a couple of things before we can figure that out. So before we move on to EFG, let's look at what we have over here. So we're going to work with this first. What do we know about these two angles? Whoa. Can everyone still see me screen? Okay, give me 1 second. All right, can you see it now? Oh, hold on. All right, good. What do we know about these two angles right here? They are supplementary. Straight line, good. What do we call that? What kind of angle pair are they? They're a special kind of adjacent angle. Good. A lot of you are saying adjacent, but when we have adjacent angles on a line, good, they're supplementary. They're supplementary. How do we know? What theorem? Oh, let's put ABD and CBD are supplementary. How do we know? Good, they add up to 180. But what theorem that we just went over lets us know? Good, I got some answers that are correct. I'm not going to type it up yet, but yes, good. A lot of you are getting it. Good, they are a linear pair, and linear pairs are supplementary. And hope you're on the right track, but you're a few steps ahead of me. That's okay. It means you understand. So they are a linear pair. Good, Noble, it's exactly where we're headed, but we didn't get there yet, okay? Suppose you were doing a proof. Once you say they're supplementary, you need to say that they add up to 180. So we're going to say that ABD plus CBD equals 180. All right, using this information, since we know that ABD is 32, we're going to put that in here, okay? And then we say that linear pairs are supplementary. Now, using that theorem that a lot of you stated before, what can we write instead of CBD? What can, good, it's going to be 148. But what can we replace CBD with using that theorem that we said before? Good, Anna, that's the correct answer. So here I kind of got, all right, in here, I know I put this, but what we're going to put is EFG, or ABD, and EFG are supplementary. Kind of went in the wrong order that I meant to, but what theorem can I use to say that? Think of the theorems that we said before. A lot of you stated it already. What theorem makes the second statement true? Good, Hafsa. I hope I'm saying your name correctly. Good, Hope, that's correct. Thanks. Good. It's not vertical because vertical they have to be two. If it was vertical, it would have to be down here somewhere. So I'm going to type it in there. A lot of you said it. Congruent supplements theorem, which says that if two angles are congruent, then they are supplementary to the same angle. So since we know that GFE is supplementary to ABD, now that we know that, we can use that information to do what I said before when I went ahead of myself, that they add up to 180. And give me one sec. and then we'll fill that into our equation, and then we'll find out that what is the value, since ABD is 32, what's the value of EFG? Good. I'm getting a lot of good answers. Perfect. It's 148. And that is just because supplementary angles add up to 180 degrees. If you were doing a proof, that's what you would write in the justification column. So this one is a little bit trickier than last one. How are you guys doing with this congruent supplements theorem? Okay. All right, good. Don't be afraid to ask questions if you get confused at any point. All right, let's go on to our next one. Now this is something that, good, a lot of students get wrong on the assignment that goes with this chapter. Whenever you have a picture, you have a lot of markings with the picture. You're going to have little dashes like these, little half circles like this, right angle signs. If you have the same markings on any part of the picture, that means they're equal. So that means that since there's one line here and there's one line here, FG is equal to AB. If you don't see any markings, saying that they look like they're almost the same length isn't enough to establish that they are. You have to have proof. And the kind of proof would be markings or one of our theorems. Okay, so if you don't have a theorem that is proving it's true or markings proving it's true, your answer is not enough information to tell. Okay, so from the following diagram, we're going to try and tell some information. Can we say that FGA is equal to AGB? Well, let's look at our picture. FGA is right here, so we start from F, because that's the first, GA. So when we say angle FGA, we're talking about this angle right here, which has a little half circle. Is it equal to angle AGB? All right, go ahead and answer that on what you think. Okay. The answer to this one is yes. The reason we know, it's okay if you got it wrong, is because they both have this little half circle. And if they both have one little half circle, that means they have the same markings, so they are equal. So how do you know? Same markings. Okay. Now let's do another one. Now, just because it looks the same, that doesn't mean it is. You have to have markings or some other kind of proof. So it wants to know, is FG equal to GH? Okay. The answer is no. As you can see in this picture, there is one little dash right here, and on this there's no dashes. So even though they kind of look like they could be the same distance apart, the question is asking, can you conclude that? You can guess it, but you can't conclude it without a doubt that FG is exactly the same length as GH. Reasoning is there's just not enough information. Okay, Now let's look at our last one. GBA, so that's an angle. We start from G because that was said first. GBA, that means we're talking about this angle right here. And it wants to know, is it equal to angle EBC, which is right here, EBC. Means it's talking about this angle here. Do you think those two, can we conclude that they're congruent from the information? All right. Now, remember the theorems we've been learning. Does that look like it could be an angle pair that we learned about? Vertical. All right, so they are vertical angles, and we can tell that from the picture. So knowing that they're vertical angles, do any of you want to change your answer? Yes, they are. Okay, good. And what theorem can you use to say they are equal? What theorem can you use to say that? Good. Yes, exactly. If it's vertical, it is automatically congruent. So it is the vertical angles theorem. When you see the word theorem, that means always true, pretty much. It means it's been proven. So that's how you know if vertical angles is a theorem. That means that vertical angles are always congruent. Now, let's go on. We're using the same picture, but we're going to try and get some more information from it. It wants to know if angle ABE and CBE equal 180. So let's look at where they are. ABE is right here, so that means we're talking about this angle right here. And then CBE is CBE. That means we're talking about this angle right here. Can we conclude from the diagram that they're equal to 180 degrees? All right. Okay. Let's look at this line right here. Okay? ABE and CBE are two angles on that line. So that makes them what kind of angle pair? Good, they're supplementary. And James, that was the answer I was looking for. So they are supplementary, but there is a special name for two angles that are on a line. Yes. All right, so because they're a linear pair, that means they're supplementary. Supplementary angles add up to 180 degrees. That's just definitions. It's just memorizing them, and it's really helpful to have them all in one place. That's why I told you guys in the beginning, write these all down in one place. If you get a new definition while you're working, add it to your list of definitions. Because that's really three different definitions working there. It's the linear pair. You can call them straight angles, that's fine. Whatever makes it easier for you, as long as it's universally understood. But that's 3 different definitions that work. That's the linear pair theorem, and supplementary angles. That's 3 definitions we just used to make this one statement. So you need to make sure you know your definitions very well. So for our justification, we would put linear pairs are supplementary or something to that effect. Sorry. All right, now let's see. Can we conclude from the diagram FG equals AB? That's FG here and AB up here. Can you guys conclude that from the diagram? All right, good. Yes, you can. And what's your justification for that? Good. All right, perfect. Yes, they have the same markings. All right, and then both have the dash, same markings. Any of those answers would be a good enough answer for how do you know. And remember, too, when you guys are doing this assignment, it does ask for both. It asks you to say, can you make that conclusion, and it asks you to tell why. So make sure you do both parts. If you haven't done that assignment already, make sure you remember to put that in there. All right, and the last one is angle FGA equal to HGC? So let's look at those 2 angles. FGA is right here. HGC, oh, it should be HGB. I apologize for that. Okay. Okay. So are those 2 angles equal? FGA. Oh. Okay. Some of you did get it and some of you didn't. The answer is you actually can't. I'm thinking maybe you thought they were because you thought they were vertical. Is that why some of you said that? Okay. Well, the difference is with vertical angles, you have 2 straight lines that are crossing each other. Okay? Here we have 1 straight line, but the other line isn't straight, so they're not actually vertical from each other. Does that make sense? To be vertical, it would have to be like these 2, where it's actually 2 straight lines crossing each other. If we extended this line, so it was like that, then the angle down here would be equal. But the angle that we have isn't. Give me 1 sec, because okay, sorry, it went away. So this would be, but we don't have that straight line going down. This angle right here, and let's call it angle X, which is the one that was we are talking about down here actually isn't equal because it's not vertical. What do you think the justification would be? Or it's not that it's not, we just don't know. So why don't you think we know? Good, there isn't markings. There's not enough information. That's all you have to put. Or not say markings. Any of that would work. All right, and that concludes the lesson for today. I recorded everything, so if you have any questions or if you want a copy of the notes or the slides, go ahead and send me a message. Thank you all for coming. And if you have any comments or recommendations, if we do this in the future, you can send those to me in the message center as well. Go ahead and send me a message through the LMS if you want me to send you the lesson. It'll just be easier to keep track of. All right, so I hope you all have a good day, and thank you for giving me your time.